Okay, continuing with solving equations, this is going to be our section 9.3. So we're still going to use our same methods to try to solve in this for x. Now, what we need to think about is like what I've mentioned before in my previous lessons, is that we need to figure out where do we want to move the x. So my rule of thumb is you take the more positive, which is, in this case, it's the 15x. So what I'm going to do is I'm going to get rid of the 12x by subtracting it on both sides. And now you get 3x minus 7 equals 5. So from this point, what I'm going to do is I'm going to put a little box right here around the 3x, protect it, and I need to move this minus 7 over by adding it both sides. You get 3x equals 12. Then this is 3x or 3 times x, so you would have to divide because you want to cancel out the 3's. You have to divide it on both sides. So as a result, x is 12 divided by 3, which is 4. Now, remember, you can always check your answers. By checking your answers, I would say 15 times 4 minus 7 equals 12 times 4 plus 5. 15 times 4 is 60 minus 7, which is 53. My other side is 12 times 4, 48 plus 5. That also gives me 53. That means I correctly solved this equation. My next one's a little bit more challenging because you have this parentheses, which means we're automatically going to distribute. So we cannot, I don't want to do anything to the left side, so the 7x plus 2 stays the same. Now what I'm going to do is I'm going to distribute the 3 over. 3 times 2 is 6. You've got an x there, so it's 6x. Plus 3 times 1 is 3. And I've got that lone x on the outside of the parentheses. So from this point, I could say 7x plus 2. Now what I'm going to do is I'm going to combine my x and my 6x to give 7x. And then I'm going to say, subtract my 7x on both sides. I get 0x plus 2 equals 3. So that means subtract 2 on both sides. X equals 0x equals 1. Divide by 0 we cannot do, so that's undefined. That means there's no solution. So you can have no solutions. You can have zeros. You can have positive, negative numbers. I mean, you can even have fractions. So now what I want us to do is let's take a look at the next one, number 3. We're also need to distribute the 2. 2 times 3m gives me 6m. 2 times 4 gives me a plus 8. Set it equal to 3 times 4m is 12m. 3 times 5 is 15. Now, in this case, the 12 is the bigger number that's attached to a variable. So what I'm going to do is I'm going to switch this equation around. Now I'm going to make this 12m plus 15 equals 6m plus 8. Since the 12 is the biggest, that means I'm going to subtract 6m from both sides. So you get 6m plus 15 minus equals a positive 8. Then what I want to do is I'm going to subtract the 15. I've got 6m equals negative 7. Divide by 6. M equals negative 7/6. Okay, guys, so now we have a fraction, and like I've said before, to shut down when we see fractions. So, my rule of thumb is this. If you have the same denominator, which is 3, we basically can just ignore it. It's a whole nother lesson why I can't explain it, but just trust me, you can just treat this as 2x plus 5 equals negative 5. Then what you want to do is treat this just like a regular equation by protecting the 2x, subtracting the 5. That gives you 2x equals negative 10. Divide by 2. And you get x equals negative 5. So the key to this is that they have the same denominators. You can just, pretty much the denominators cancel each other out, and you are left with that 2x plus 5 equals negative 5, and just solve it like what we've been doing. So now the final problem of this unit is having fractions with different denominators. So what I'm going to do starting off, this is 3/4 x minus 1/2 equals 8. So I'm going to protect the 3/4 x. So what I want to do now is I want to add 1/2 to both sides. So I've got 3/4 x equals, now over here at the right, 8 plus 1/2 is the same as 8 and 1/2. Now, if you can recall from mixed numbers and improper fractions, you would just say 2 times 8 plus 1. So 2 times 8 is 16 plus 1 is 17, and you keep the same bottom number or the denominator. So now what happens is we put (17/2) on the right side of the equation. And one reason why I do like this example too, this is understanding, okay, we can divide by 3/4, but if you can recall when you divide by fractions, all you're doing is taking the reciprocal, or you're flipping the fraction. Because now the 4's cancel and the 3's cancel. What you're left is with x. But like in any kind of equation, if you do to one side, you have to do to the other. So I'm going to multiply the 17 over 2 by 4/3. And one little trick I'm going to show some of us, if we can remember, we can recall, is 2 goes into 4 2 times. 2 goes into itself 1. So now we can say 17 times 2, which is 34 over 3. Now, depending on how you're asked, this could also be 3 goes into 34 11 times, which makes 33. So that means you have 1 remaining. You can put that over 3. So it depends on what your question is asking, whether it wants it an improper fraction or a mixed number. So I hope this does help. My next video, I'm going to continue working with solving equations. So I hope that you will tune in and follow me on my next video.